the nucleus will have 4 electrons in the shells is, if here we had high and the attraction for the electrons by the nucleus was also high, and here we are having low, what would happen to the attraction of the electrons? The attraction of the electrons would be also low, is low, leading to increase in the atomic radius. So simply that is how the nuclear charge affects the atomic radius. Let me try to elaborate it. When we try to elaborate it, we are saying that if an atom has high nuclear charge, for example, taking examples in group 1 elements, sodium and potassium. Sodium has 11 and potassium has 19. All of them, they have only 1 electron in their outermost shells. Potassium has 19. So if these are atoms of sodium and then these are atoms of potassium, remember we said identical, closest approach of identical atoms, and all of them are having the nucleus. We are saying that if the atom has higher nuclear charge, this one is only having 11 and this one is having 19, which means the forces that the nucleus will have on the attraction of these electrons in the shells will be low, compared to the one of potassium where we are having 19 electrons. And remember we said the number of electrons is equal to the number of protons in the nucleus of an atom of an element, such that at the end of the day the element is neutral. You look at potassium having 19 protons, and these 19 protons will increase on the effect of pulling the electrons in these shells. So they will pull the shells will a little bit come more closer to the nucleus, reducing the atomic radius. That is why we are saying that if the nuclear charge is high, the attraction of the nucleus for the electrons in the outer shells is greater. And when it is greater, when those electrons are attracted, you can take an example of this marker. If all electrons are attracted closer to the nucleus of the marker, the distance will be reducing. That is why we are having the atomic radius decrease if the nuclear charge is vice versa. And then the reverse is true for sodium. The reverse is true for sodium. That means that sodium with a smaller nuclear charge, the attraction of the nucleus for the electrons in the shell will reduce, giving us a bigger atomic radius, giving us a bigger distance of closest approach between two identical atoms. Then the other factor is what we call the screening effect. The other factor is what we call the screening effect. Under the screening effect, this is the tendency of inner electrons to shield off or to shield outer electrons from nuclear attraction. I don't know whether you had numbered the other one, so let's say this is B, the screening effect, which is defined as the tendency of electrons, the tendency of inner electrons to shield outer electrons from nuclear attraction, is the tendency of inner electrons to shield outer electrons from nuclear attraction. From nuclear attraction. This can be elaborated as, if this is our nucleus and then we have this as our shells. So the screening effect would be the tendency of these shells 1, 2, 3 to shield the electrons in the first, second, and third energy levels, to shield outer electrons, the ones which would be in the fourth, energy level from the nuclear attraction. This would be seen in human beings, whereby the last born shields off the love from the parents from the firstborns. In most cases, you find that if there has been a child and then they have given birth to another one, all attention that was initially given to the other child is now given to the one who has been born. That is the same case with the screening effects. The electrons closer to the nucleus tend to shield off attraction. They tend to chase them away. They reduce the forces of attraction between the nucleus and the electrons in the outermost shell. So you find that our electrons in the outermost shell are loosely attracted to the nucleus, and that makes the outer shell a little bit go further away from the other shells. So you find that the nuclear, the other four shell will be very far away from the nucleus because the forces of attraction are weak. And if this is our atom, we are saying that if the screening effect is big, it will increase the atomic radius. And if the other case where we had like this, it would decrease the atomic radius. So that means increasing the screening effect reduces the attraction of electrons in the outermost shell from the nucleus, making the atomic radius greater, or what we call big. High screening effect reduces the attraction of the outermost. When we say outermost, we are meaning those electrons in the last energy shell. Those electrons in the last energy shell. High screening effect reduces the attraction. Sorry about this. It is attraction. Reduces the attraction of the outermost electrons and when it reduces the attraction of the outermost electrons, what happens to the atomic radius? The atomic radius increases. Outermost electrons, thereby increasing the atomic radius, thereby increasing the atomic radius. So what would happen if there is low screening effect? That means that if there is low or no tendency of the electrons to shield the nuclear attraction from the outermost electrons, what would happen? Which means the atomic radius would be low. So I expect you to write this and tell me what happens if there is low screening effect. Because we've looked at the case when it is high. When it is high, what happens? And when it is low, what happens? After writing that, we are going to look at the variation of the atomic radius across the period. Variation of atomic radius across the period. Variation of atomic radius across the period. Remember, we defined a period as the horizontal arrangement of the elements in the periodic table. So we want to see this horizontal arrangement. What would happen to it in terms of atomic radius? And we have that atomic radius decreases across the period. Atomic radius decreases across the period. Atomic radius decreases across the period. And why is it that atomic radius decreases across the period? That is because the nuclear charge increases due to addition of an extra electron in the outermost shell. Remember, we say that for an atom to be neutral, if you add an electron, then a proton is automatically added. A positive plus a negative, you get a neutral point, the one we call 0. So we say that across the period, that means moving from period to period. Let me give over. So I'm taking an example, but this should be around period 3, where we have sodium, we have magnesium, we have aluminium, and we are having sodium having 11 electrons or 11 protons. we are having magnesium having 12 electrons or 12 protons, and we are having aluminium having 13 protons or electrons. So what we were meaning, across the period, an electron is going on being added. And once you add an electron, that means there would be automatic addition of a proton. And a proton brings about the increase of the nuclear charge. And from the first effect of nuclear charge, we saw that the greater the nuclear charge, the smaller the atomic radius. And the smaller the nuclear charge, the greater the atomic radius. That is why we are having our atomic radius decrease across the period due to addition of an extra electron in the outermost shell due to the addition of an extra electron in the outermost shell, which brings about an addition of a proton to the nucleus, and the addition of a proton to the nucleus increases the nuclear charge, and this